This is the notes for 1.2, tables, graphs, and equations. Yesterday we looked at your classmates' walking rates and we turned them into equations. Our goal today is to connect that to tables and graphs as well. Okay, so I made a little note down here. In our scenario, it says Gilberto's walking rate, as the time increases by 1 second, the distance increases by 2 meters. So we're putting in time as my independent, and I'm getting out distance in meters. How we would say his rate is 2 meters per second. Okay, so let's look at how do we see that in a table. Okay, so to start off with, if I was to go from 0 to 2, I would increase 2 meters for from 0 to 1 second. I went 2 meters after 1 second. Or what they have highlighted for you, he went up 4 after going for 2 seconds. We can also see that as the distance from 0 to 6. If he goes 6 meters, that took him 0 to 3 seconds. Okay, so we'll notice all of those are a pattern that's consistent. We can simplify every single one to 2 over 1, 2 meters per second. Whether it's he raised 2 distances after 1 second, 4 after 2, or 6 after 3, all of those rates are the same. Okay. It's important to note though that my rate of change is my dependent, what I'm getting out over my independent. So I got out 2 meters after walking 1 second. Okay. In a graph, we call that our slope here, and it's the vertical change to the horizontal change. So in their picture, they've highlighted for you after 2 seconds, he went 4 meters. That's right here. Or after 3 seconds, he's gone 6 meters. Or from here, 2 to 1, let's go from this point to this point. After 2 meters, it's been 1 second. Okay. The important thing again is make sure it's the vertical to the horizontal. So just like in our table, we were getting out his distance, same thing here. My vertical change is what he's getting out. He's going 4 meters for every 2 seconds. How much my slope is, how much I rise compared to my run. And then the last one in my equation, it's the coefficient. The coefficient is the fancy math name for saying it's what I times by my variable. Okay, so right here, that 2 is my coefficient. We are multiplying time t by 2. That's my slope. Okay. All right, I have another example we're going to look through. Go ahead and set your notes here to this side. We're going to try an example together. This next one, though, you do not have to write down. I just want you to go ahead and watch. Okay. All right, so Randy walked 10 meters in 8 seconds. So let's try an example together. So at 0, she's gone 0 meters. Okay. After 1 second, well, if she's gone 10 meters in 8 seconds, if it's 1 second, with my calculator, building off of last unit, we're going to do 10 times 1 divided by 8. She's gone 10 meters divided by 8 seconds, and we find that our unit rate would be 1.25 meters per second. Okay, so that's our idea. She's going 1.25 meters per second. I can keep using that proportion if I'd like, or I'm just going to simplify mine. If she goes 1.25 meters in 1 second, and we're trying to figure out how far she goes in 2, we're going to take 1.25 times 2 divided by 1. My 1.25 for 1 second, so if she goes 2, I double that, she'd be at 2.5 meters. If we were to put in a 3 right here, 1.25 times 3, she would have gone 3.75 meters. After 4 times 1.25 is 5 meters. And that last one, just so we can see it in our graph, if she was to go 10 times 1.25, when I divide by 1, it'll stay the same, and we would get 12.5 meters. Okay, so we know our unit rate is 1.25 meters per second. How we see that in our table is what we add every time. Okay, so just like I highlighted last time, from 0 to 1.25, she gained 1.25 meters after walking for 1 second. Or we can make the comparison, let's just say between these two. From 2 meters to 5 meters, now she's gone 2.5, but from 2 to 4, that was over 2 seconds. So 2.5 and 2 is the same as 1.25 to 1. I see that same rate as meters per second. Okay. Just keep in mind my table though, that constant rate is getting added. Every time when I multiply by 2, by 3, by 4, it just adds another 1.25 meters every time. Now let's go to our graph. So at 0, she's at 0. After 1 meter, get a little space there, she's gone 1.25. 8, 9, 10. So it looks something like that. After 2 seconds, she's gone 2.5 meters. After 3 seconds, we're putting in time, that's my independent variable. I get out 3.75 for my distance. I put in 4 seconds, I get out 5. And then last one, if I put in 10 seconds, I should get out 12 meters. Notice how that connects and makes a straight line. Okay, I have a consistent rate, that's our theme for this unit. In every case, she's going up 1.25 meters per second. So from here to here, she went up 1.25 and over 1. Or we could compare, for example, from 4 to 10, right? So from 4 to 10, she went up 7.5 meters, but when I divide that by 6 seconds, that 7.5 to 6 will still bring us back to 1.25 meters per second. Okay, so in our graph, we saw it as I was consistently adding 1.25 meters every time. In the graph, what that turns out to be is that I'm going up 1.25 for every meter. I go up, whatever my table is adding, that's how much my graph goes up for every 1 second. Okay, and then the last one is an equation. So in our example, she was going 1.25 meters per every 1 second. So as these variables change, let's say meters, we'll just call D for distance, and T was our time for seconds. I'm always taking 1.25 times time, and divided by 1 will give me the same answer, so that's why we don't have to write divide by 1. Okay, so in our equation, we're taking 1.25 for every second, and that gets us out our distance. So remember, our fancy math name was coefficient. Okay, and that's what I was taking times my variable. So my coefficient was my rate of 1.25 meters per second. Okay, if I'm continually adding, that is the definition of multiplying. So when I turn this into an equation, it'll always be multiplied by my variable. Okay, my constant rate, in order to increase by that same every time, repeatedly adding turns out to be multiplication. So whatever I multiply by my variable, that's what we can also find as our slope. Okay, so today with your partners, there's 3 graphs that you're going to analyze. We're finding our rate, so how much she goes up in distance per time. If you make a table, it's how much distance, again, goes up, so it should be added per time. But once I transition that into an equation, repeatedly adding turns it into a multiplication.